Okay, this is Student Notes 12.2, Translations. This unit and this lesson is one of the easiest you will see all year long. So we're just going to start off with a few easy diagrams. In the following diagrams, explain the change that occurs from the unshaded figure to the shaded figure. So here's the unshaded and changing it to the shaded. Clearly this is a reflection, which we learned in yesterday's lesson. And here is your line of reflection. So you're just going to flip over that line. Okay, and letter B, this is not a reflection, but rather this figure is just shifting down a little or to the right, or we also call it a slide. So this is a translation. A translation is just a big long word for the figure is just sliding to the right, left, up, or down. Okay, so here's the formal definition of a translation. A transformation where all points of a figure are moved the same distance, the same distance, and in the same direction. And this is an example of isometry. Okay, isometry just means you're changing the figure from the first one to the second one, but you're not changing the size of the figure. You're just changing maybe where it is, the location, or something like that. And the types of isometry that we will be using are reflection, which we learned yesterday, because you're not changing the size, you're just flipping it over. A rotation, which we haven't learned yet, and a translation, which we are learning today. Okay, so those are called isometries. You're changing the shape, but you're not changing the size of it. So remember that the pre-image of the is the original shape. So the first image that you see is the pre-image, and the image is the new shape. So once you move the image or the pre-image, it becomes the new image or the image. And it's called the new shape. If the pre-image is represented by A, then the image is represented by A prime. It has this little apostrophe. So the original will be A, and once it's moved, it's called A prime. For example, here we have an original heart. So this is called heart T. And once we move the heart down and to the right, we draw the new heart, it's now called T prime. So this one is the pre-image, and now once you move it, this is called the image. Okay, we'll look at 1B in class. Example 2, use the function f of x equals x plus 2 to find the following images and pre-images. Okay, so find the image, so the new shape of f of 8. All this is saying is that x is 8. So we're just going to plug in 8 for x. And we want to know, once we plug in 8 for x, what does it become? The new image is 10. All right, but then careful here, determine the pre-image. Okay, so we already have the output. In other words, we already have the f of x. So we have this, the -3. This is the image. We need to go backwards and find the pre-image. So instead of plugging -3 in for x, we're going to set it equal to -3. So there's where we're putting our -3. So -3 is equal to x plus 2. Get x by itself by subtracting 2 from both sides. So -3 minus 2 is -5. So the pre-image is -5. If we were to plug in -5 for x, -5 plus 2 would give us our image of -3. Here we're going to save example 3 for class A and B. So go ahead and turn over to the back side of your notes and look at example 4. Use the transformation if the original or the pre-image is just xy, and then the new image is just changed to x plus 5 and y minus 2. So what this means is if we have an original x and original y, we're going to add 5 to the x and subtract 2 from the y to find the new image. So if this is just our pre-image, the reason this is our pre-image is because it doesn't have an apostrophe. If it has an apostrophe, like this guy right here, this is called S prime. That means it's been moved. Z prime, this one's been moved. So this is the original. So we're just going to go ahead and plug in -8 for x. So -8 and then plus 5, because that is what our rule says to do. -8 plus 5 is -3. And then plug 0 in for y. So 0 minus 2 equals -2. So our new image is -3, -2. Okay. But if you look at B, we already have the new image. We have the image because S prime means it's already been moved. So we have to find the original. So we can't plug -5 in for x, because this is where it would be if we had already moved it. So what we have to do is we have to take our transformation and make it equal to where we know it will end up. We know it's going to end up at -5. So you have to figure out what does x need to be for it to end up at -5. Well, we would solve for x. So x would have to start at -10, and then you do the same thing for the y. Instead of plugging in -6 for y, you set it equal to -6 to find out where y needs to begin. So we'd add 2. So y is equal to -6 plus 2 is -4. So the pre-image, because we already have the new image or the image, the pre-image would be -10, -4. Okay, and we're going to save C and D for class. Let's look at example 5. Consider the translation of A from A is 2, 4 to A prime is 3, 1. So how did it change? It went from A to A prime. Well, the translation rule just means what did you change with your x's and what did you change with your y's. So with our x's, we went from 2 to 3. So all that means we did was that we added 1 to our x. And what did we do with our y's? We went from 4 to 1. So we subtracted 3 from our y's. So our rule for this translation is x plus 1 and y minus 3. Okay, so let's use this rule to answer some questions. Let's look at B. Under this translation, find the image of M 3, 1. So find the new image. Image is always a new image. So M is our pre-image. So this is what we're going to plug in to our rule. So this is our x and this is our y. So 3 plus 1. If I plugged in 3 in for x, we would get 4 would be our new image. And then 1 is our y. So 1 minus 3 is -2. So our image, if we started off at 3, 1, we would now be at 4, -2. So this would be your M prime because we have moved it. Okay, we're going to look down at letter D here, which says find the pre-image of C prime, which is 6, 10. So now we need to find just C. We need to go backwards and find where it started out, finding the pre-image. So instead of plugging 6 in for x and 10 in for y, we have to set them equal to 6 and 10. So x plus 1 is our translation rule for the x's, and we know that it's going to end up at 6. So we're going to solve for x, subtract 1 from both sides. So x is 6 minus 1 is 5. Okay, we'll do the same thing with the y's. We're going to set 10 equal to the y minus 3, or y minus 3 is equal to 10. And once we solve for y, we add 3 to both sides, so 13 is equal to y. So our pre-image, or where C began, was at 5, 13. Okay, we're going to save letter C and E for class tomorrow, and also save number 6, or example 6 for class tomorrow as well. So I will see you guys then.